Hello everyone and welcome to this hands-on lab on RAG evaluations. In our lab today, we will learn how to evaluate information retrieval and response generation capabilities of an AI model using Amazon Bedrock. These are some reference URLs that I've mentioned over here. I would recommend that you visit these URLs as they have additional information on this particular topic. I've also mentioned a couple of URLs for free online JSON formatters. If you're using an existing formatter of your choice, you can continue to use it. If not, you can use these free online formatters as well. I have created a playlist for Amazon Bedrock on my channel. The URL is mentioned right here. As I create additional tutorials and labs, I will have them added to this playlist. Both the reference URLs and the URL to the playlist will be mentioned in the description of this video. Scenario for a lab today. We need to create an Amazon Bedrock RAG evaluation job to evaluate information retrieval from data sources and response generation using these four items. The first thing that we will use is a LLM model or an AI foundation model. Second is an Amazon Bedrock knowledge base. Third is a custom prompt dataset. And finally, we will use a few chosen or a selected set of metrics to perform this evaluation. Before we continue further ahead, a couple of things to keep in mind. You can use either US East, that is North Virginia, or US West, that is Oregon region to do this lab. These regions will support foundation models that are used in this lab, primarily Anthropic and Amazon Nova Micro 1.1 version 1.0. So that is one of the key models that we'll be using. If you are using any other foundation model, you are free to do that, but just ensure that it's supported in your region and most importantly, check its pricing. So these services and some of the models that we use are extremely expensive. So please ensure that you check its pricing, otherwise you can get burnt. And this is the most important point. I always emphasize about this in all of my labs. Kindly ensure that you delete or release all resources after completing this lab. So this is an absolute must. It's a discipline that has to be followed because a lot of these services and some of these models that we'll be using in this lab can be very expensive. So I don't want anybody to get burnt and get a nice long bill from AWS. So let's get started. Step one. In step one, we will be creating three S3 buckets. And these are the names that I will be using. I will also create a folder named output in my output bucket. I'll be setting the course policy. You can copy the policy from here. The URL will be mentioned in the description of this video. If you don't want to copy, you can simply pause the video and type it out. It's pretty small, so it shouldn't take that long. So right here, I'm in S3. Let's create a bucket. And I will give the name my model eval input. So my model, eval input. You can give any name that you like. Just ensure that you remember the name. So scroll down and right here at the bottom, we have an icon for create bucket. Let's create another bucket. So click on create bucket again. And this time we will give the name as my model eval output. Scroll down and again, click on create bucket. And finally, the last one is going to be my KB, bucket. So I hope that this name is available. So scroll down, create bucket. Okay, it's not available. So my no bucket. Okay, this name has also already been taken. So my knowledge base S3 bucket. Okay. So let me copy this. So this is the name that I'm going to give and click on create bucket. And let me see if I have my notepad ready. So 3 S3 buckets. Okay, so in, out, and this one, the one that we just created. So I'm keeping a track of all the resources that I'm provisioning. I would recommend that you do that as well, so that it becomes easier for you to delete or release them. Now let's go to our output bucket and create a folder. So I'm going to give the folder name as output. Again, you can give any name that you like. Scroll down and click on this create folder. So we have completed these 2 steps. Now we'll set the course policy. So I believe I have that link open right here. So this is the link. Okay, it will be mentioned in the description of this video under reference URLs. Just go ahead and copy it. If you don't want to copy it, you can type it as well, but I'm just going to copy it. So this is my output bucket. We need to set this course policy for both our input and output buckets. So click on permissions. And then if you scroll down, let me see. Here is course. So click on edit and paste the policy right there. And click on save changes. Similarly, if you go to your input bucket, this is our input bucket right there. Go to permissions, again scroll down slowly and there is course right there. Click on edit and paste this policy here again and save changes. So we have completed step 1. In step 2, we will select a set of documents, preferably white papers or any documents that you like, and we will upload these documents in our knowledge base S3 bucket. Now what I have with me are some white papers, and this time around I'm going to use some security and risk compliance white papers. So I'm going to upload these 3 white papers to my knowledge base bucket. So let me go to buckets. This is my knowledge base bucket and click on upload, add files, and white paper is right there. So I'm going to select my DDoS, my security. Oh, it's only allowing me one at a time. Okay. Security. And let me select DDoS. And let me select risk and compliance. So I'm selecting 3 white papers. Please be very careful not to select a lot of content. You can use any documents that you like. If you have a lot of content, it will take a significant amount for your knowledge base data sources to sync. Also, behind the scenes, we are going to create a vector store. So the more amount of data that you have, the larger will be the vector store and it will become eventually expensive as well. So let's click on upload and that will upload these 3 documents. So documents have been uploaded successfully. So we have completed step 2. In step 3, we will now go ahead and create a knowledge base using Amazon Bedrock. So let's go here. Let's go to Bedrock. Now, knowledge base creation, I've done a lot of labs, so most of you should be aware of it. So this is Bedrock, knowledge bases. And let us see the steps. So we go to Bedrock, knowledge bases, create knowledge base with vector store, provide the name and description, create a new service role, and choose S3 at your data source and click on next, and then provide a data source name. So let's complete some of these steps. So this is here it is. This is our Bedrock knowledge bases. Click on create knowledge base with vector store. Now we'll give a knowledge base name. So my know base. I'm giving this name. Please make a note of this. I'm going to copy this as a description, create and use a new service role. So let's copy this as well. We are going to provision this role. Data source select as Amazon S3 and click on next. So we have completed these steps. Now we will select the data source location as this account. Choose the S3 URI as our knowledge base bucket. Keep the chunking and parsing default and click on next. So this account, let's choose our knowledge base bucket. Chunking and parsing strategy, everything is going to be default and click on next. Finally, we have to choose our embeddings model. So I'm going to use this one. You can use any one that you like. Just ensure that you have access to the model, and most importantly, check its pricing. And finally, we will create a vector database. And in this case, select basically create a quick new vector store using Amazon OpenSearch serverless. And finally, we will go ahead and create a knowledge base. Please be patient. Creation of this knowledge base takes a while, and wait until you get the message saying that your knowledge base was created successfully. Okay, so this is a very patient step. It requires a lot of patience. So Amazon Titan Text Embeddings V2, this is my model. You can use Embeddings G1 as well if you like. Then vector database, select the option quick create a new vector store using Amazon OpenSearch serverless. So remember that this was actually going to create an open search vector store, and just remember to delete it. Now this is a very expensive service. Okay, Amazon OpenSearch serverless. So ensure and remember to delete this database, this data store. Next, everything looks good. Review it and click on create knowledge base. So it's preparing a vector database and it's going to take a few minutes. So this process is going to take some time. I'm going to pause the recording over here and then come back once a knowledge base has been provisioned. So our knowledge base has been created successfully, as you can see over here. And let me go to the steps. So the next thing for us is to sync our data sources for our knowledge base. So let me go here. It is actually also telling us that one or more data sources have not been synced. Go to data sources. So this is the data source. Let's select this data source and click on sync. So the status is syncing. It is syncing our data source. Again, this is a time-consuming process. We only have 3 documents, so hopefully it should not take a lot of time, but be patient. So our knowledge-based data sources have synced very well. The sync is complete, as you can see over here right at the top. So let me get rid of this message. And now it's time for us to test our knowledge base. So we have completed step 4, and let's test our knowledge base. So we will try and ask a question to a knowledge base. So let me select a model. You can choose any model that you like. I'm going to use Amazon Noah Micro 1.0. And let's see. I'm going to start with hi. So let's see what it has to say. Okay. And it is telling me so many different things. Fine. Let me quickly go to my white paper, and I have a paper on DDoS. So let me open it up. And we will ask something from this white paper. We can probably ask maybe what is DDoS? You can again, depending upon your choice of documents, can ask any question that you like. So we will say, copy this, go back to your knowledge base, explain denial of service attacks. So click on run and show details. So it's basically given me this response, and it has used almost 11 data sources. So these are different source details over here. So source 1 is from here. And let's see where it's coming from. It's coming from DDoS white paper, page number 5. So let me go to, this is page number 6, and it probably has something over here on page number 5. So you have is starting from page number 5, but it's also there on page number 6. Let's see source chunk 2, page number 5 again, and over here, page number 5, DDoS white papers. So this is page 2, this is page 6 on the top, and this is page 5. So it's basically treating this as an extension. Let me see if there is a 2 page number. So one that is written over here and one that is over here physically. So as part of the document. So page 5, this also has some explanation of DDoS. And if we scroll down, let's go to the last one to see where is this one coming from. This is coming from page number 6. So I think it's taken most of its information from pages 5 and 6 from that particular document. So our knowledge base is working fine. So our test is complete. If you want to chat further with your knowledge base, you're more than welcome, but I'm just going to complete the test right here. In step 6, we will be creating a custom prompt data set, and we'll be leveraging Amazon Q, the free tier version, in order to do this. Now, do not create a lot of prompts, just create like maybe 3, max 5 prompts. For every prompt the model processes, you are charged for it. So since this is for learning purposes, I'm only going to create 3 prompts by giving it an input record. Now, if you want, you can create your own prompt data set as well, but I would like to use Q to do this job for me. So this particular URL is mentioned in the description of this video, and I have it open right here. Let me close this one. So this is the URL, and create prompt data set. This is for retrieve only, but the same thing will also work for retrieve and response generation as well. So go and copy the prompt from here and paste that in your notepad. Let me just zoom in. And what we need to do after copying this is we need to make this compact. So I'm going to again close this. This is my JSON formatter right here. So let's paste this and scroll down and click on minify/compact and copy this. Copy. Now go back to your notepad and paste it right there. So this is our sample record. So we have copied that successfully and we have made it compact. So step 6 is over. In step 7, we will be using Q developer free version to create a few more examples. Now, how are we going to do that? We already have the sample with us. So what we are going to do is we are going to create this whole prompt, which says create a few sample records for automatic Amazon Bedrock knowledge base evaluation, that is retrieval and response generation using this example. So we are going to tell Q to do this. Finally, the 3 sample records that Q generates we will have those sample records copied in this batch input.json file. So let me quickly copy this from here. I have it typed out, so hence I'm copying it. It's not that big, so you should be able to type it out easily. So I already have this typed out, so I'm going to copy this and paste it right here in quotes. And put this entire example in double quotes as I have done over here. So create a few sample records for automatic Amazon Bedrock knowledge base evaluation, retrieval and response generation using this example. So copy this whole thing. Now go to Q. So go back to your Amazon console, close this. This is your Bedrock console right here. And go back to the overview. Get rid of this. Go to Q. Q is right here in the right-hand corner. Click on that. This is the free tier version. Paste it and hit enter. So hopefully it generates 3 sample records for us. Okay, it's giving us the steps. And this time around, just created 5 sample records. Perfect. So it's created 5 sample records for us. So what I'm going to do is I am going to copy these. Copy. Go back to my notepad and paste them right there. So this is the first one, second one, third one, fourth one, and fifth one. And let me remove this from the top. Get all of these records together. So remove spaces. Okay, so it's created 5 records. And what we are going to do is we are going to save this. So save as. Let me go to Bedrock and all documents. And I'm going to say batch input dot JSON now and save it right there. So we have 5 records and we have basically completed step 7, right? So this step is complete. We will upload the batch input JSON file to our input bucket, and post that we will create a RAG evaluation job. So let me go to S3. This is our input bucket. This is our input bucket right there. Upload, add files, Bedrock, my batch input JSON file, open, scroll down and click on upload. So this has been uploaded successfully. Now it's time for us to create our evaluation job. So this is a RAG evaluation job. So we will go to Bedrock, Inference and Assessment Evaluations for RAG. And then over here, we will give a RAG evaluation job name and description. We will create this job using an evaluator model. I'm going to use Anthropic Cloud 3.5 Sonnet and select our data source as Bedrock knowledge base. Select your knowledge base and select the evaluation type as retrieval and response generation. So let's finish some of these steps. So let's go to Bedrock. Inference and assessment. This is inference and assessment evaluations. We are trying to perform a RAG evaluation. So click on RAG, click on create, and here we will give a name. So my RAG eval job. So give this name right there. Let me make a note of this as well. Now we have to choose and evaluate a model. So click on select model, and I'm going to choose Anthropic Cloud 3.5 Sonnet, apply. Inference source, we are going to choose Bedrock Knowledge Base, and we are going to choose a knowledge base. Evaluation type, we are going to choose as retrieval and response generation. So we have completed all of these steps all the way until here. Now we have to select our generator model. I'm going to use Amazon Nova Micro 1.0 and select our task type as general text generation. I don't know why I always have that task. Okay, let's select that. Amazon Nova Micro, apply. Okay. So scroll down. So this task, apologies. This task is not there. Sorry, it's my mistake. This task is not there. So remove this task. So the next thing that we have to do is under matrix, select our quality and responsible AI matrix. So what we are going to select is helpfulness, correctness, and harmfulness. Let's go back. So matrix, quality matrix, we are going to select helpfulness and correctness. And for responsible AI, we are going to select harmfulness, which is selected in this case. And finally, we have to select our data set for evaluation. So let's select our input data set. So go to our input bucket and select our batch input JSON-L file. And for our output, let's select our output file, output bucket and our output folder. And so we have completed these steps. Finally, we will create a new service role by providing a name, note down its name, and then click on create. So we will create and use a new service role. Copy this, paste it right there. Remember to delete it and click on create. So if everything is fine, this creation will go ahead successfully. If not, it will give us a message that it was not created successfully. So it's trying to create an evaluation job. It may take a few minutes. I'm going to stop the recording and come back once the job is created. Oh, there it is. I believe it has already created the job. So there it is. My RAG eval job is in progress. And it will take a few minutes for it to complete. So I will come back when the job has completed. So I'm pausing the recording. So our evaluation job has finally completed. So let me go here. So step 9 has finished and it's time to review the output. So let's go back and let's click on our job right here. So we have selected 3 metrics. We have selected for quality, correctness, and helpfulness. And for responsible AI, we have selected harmfulness. We had 5 prompts. So let us go ahead and look at the evaluation. So the first 2 metrics that we have is quality matrix, helpfulness, and correctness. So for helpfulness, 3 prompts are between 0.67 and 0.77, and 2 of them are between 0.77 and 0.83. So let us scroll down and look at the example conversations. So conversation 1, retrieval score is 5, 5, 5, and 5. So all of them are 5. And if I can click on that, so it's showing me the source, view source. Risk and compliance white paper is going over here. So that's the source. Perfect. So not that bad. The retrieve sources, generation output. Okay, I don't think this is showing this completely, but any which ways, we will. So 1, 2, 3, 4, and 5. So our retrieval scores are 5 for correctness. Most of them, 4 of them are between 0 to 0.1, and 1 is between 0.9 to 1. Let us look at the example conversations. So the retrieval scores are again 5, but the correctness matrix are different. Okay, and for harmfulness, that's a responsible AI metric. I don't think any of the scores are harmful in nature. So this is what it is. Now let us go and look at the output folder. I don't know where can I go back maybe? Evaluations. Let's see if something is there in the output folder that we had suggested earlier. And from here again, it's again bringing me back to the same page. Example conversations. Okay, so otherwise I will have to go directly to S3. Our output bucket, output folder, my rag eval job, permission check, inference configs. Let's see if anything else is there over here. Rag dataset. This is our output JSON file. Let's click on that and click on open. So it's downloaded a file. I'll basically click on open. Okay, so this seems to be a significant amount of data for our 5 prompts. Okay, so I'll have to figure out one record over here. Conversation turns. Let's see if I can copy one record. Okay, this is pretty long. I hope I didn't miss it. Okay, let me just copy the whole thing and see if I can go to a JSON formatter. Close this and put it right here. Remove this. Paste. Format and beautify. Yes, I thought so. It will get confused between multiple records. Okay, so let me do this. Copy. Find this again. Next. Okay. So this is for one record. It's pretty long. Control V. And there it is. So let's look at this in full screen. So what is the warranty period for your product? This is our product comes with a 1-year standard limited warranty from the date of purchase. Amazon Nova, knowledge base identifier. So this is what has come over here. The model cannot find sufficient information to answer this question about the warranty period for the product. The provided search results do not contain specific details regarding warranty periods. That is good. Management AWS monitors electrical, mechanical, and life supporting systems equipment. So these are some retrieval results that it has got for business continuity. This is from this security white paper. This is additional information from risk and compliance white paper. Again, some additional information from risk and compliance white paper. So it has done multiple retrievals over here. Generated response text. The model cannot find sufficient information to answer this question, which is right, because this is a general question and our knowledge base has information about security and some retrieve references again from the security white paper, document ID. And that's why this response is so long. So as you can see, there are multiple responses that have been retrieved for this from different white papers from our knowledge base. Okay. So again, it is saying for accurate and detailed warranty information is recommended to refer to the official product documentation. Okay. So it did attempt to retrieve a lot of information, but I don't think that that information is relevant, right? So built-in helpfulness. So the completion accurately acknowledges the provided information does not contain any details about the warranty periods, and hence this is the result. This is the score. So for helpfulness, of course, it did a lot of retrievals, but the context is not there, so it's not very helpful. So score is relatively low. Correctness, of course, it's not correct because, I mean, the question that we are asking versus the information that we have in a security white papers has nothing to do with each other. Okay, so the correctness result is 0. So it's definitely not correct. And there's absolutely nothing harmful about this. So the result is 0 again. So this is our first record. Now let us look at the next record. So let me see how long is this. There's no point in scrolling sometimes, I feel. Okay, let me again use the same method. So right from here all the way until the top. Okay, this is a long, long record. Okay, so this is one record. Again, let me go back to the formatter. And paste it right there. How do I reset my device to factory settings? Again, let me simply just scroll down after all the retrievals. If we let's look at the scores, right? So for helpfulness, I mean, the candidate provides a clear step-by-step guide as to how to reset a device, reset a device for factory settings. So it's probably found it helpful. Model identifier is Cloud 3.5 Sonnet. Correctness is 1. The response, it seems, is pretty decent, and there's nothing harmful about it. Okay, so to reset a factory device, reset a device, go to factory settings, etc. So it's basically evaluating this. The retrievals are there, but I don't think the retrievals are relevant in this case. So harmfulness makes sense. There's nothing harmful about it. Correctness, yes, the response is correct. And helpfulness, yes, the answer is pretty helpful as well. But our retrievals over here are pretty much irrelevant. So let's look at that. And if you want, we can look for one additional record. So this is the next record that we are looking at. And these records are really very, very long and tedious. I don't like these records as much. So let me come out of this, go back here, paste it right there. Let's look at it in the full screen mode. So let's look at what we have. What are the operating temperature ranges for outdoor equipment? Our outdoor equipment is designed to operate safely in temperatures ranging between minus 20 degrees centigrade to 50 degrees centigrade, and this is in Fahrenheit. So multiple retrieval, again, the model, of course, cannot find enough information about this in a knowledge base, but it has tried to get some information from across different white papers. Let me scroll down. Yes, there's nothing harmful about it. So harmfulness is 0. Correctness, the candidate response states that it cannot find sufficient information to the answer question about operating temperature ranges for outdoor equipment. However, the ground truth answers provide specific temperature ranges for outdoor equipment. The candidate response does not align with the ground truth as it fails to provide correct information that is clearly stated in the ground truth answer. Okay, and helpfulness. The completion correctly acknowledges that the provided information does not contain specific details about the operating temperature ranges for outdoor equipment. Hence, the score is on the lower side. So this is how you can go about evaluating any of these models. Basically, we did both the retrieval and the response generation evaluation against these 3 different metrics, that is helpfulness, correctness, and harmfulness. You can choose any other matrix that you like. So hopefully this lab was helpful. Do post your comments, and yes, these responses are going to be very lengthy. So use a decent JSON formatter to navigate around. You saw me struggling to even get one single record. Yes, it can be a pain. So do post your comments. If you are new to my channel, do like and subscribe. And if this was helpful, post your comments and like. Thank you so much. Have a great day. Bye bye.